Okay. Hey, welcome here, everyone. Thanks, Kai, for your part of the story. And this is like the first combination of the town hall sessions and the SaKE. For the people who didn't perform or participate to SaKE before, it's like a bi-monthly knowledge sharing session that came from like the digital organization. But let me see a show of hands. For who is this the first time they're participating in a SaKE? Whoa! Like for the people at home, half the room went up. There's also some newcomers, so it's we don't blame you for not participating before. But it's a session that originated as the Bier en Pizza avond on the Maasluisstraat, where we just had some techies in a room ordering pizza and talking about technical subjects. And over time it grew. People were really disappointed if they missed an episode, so we started recording it. And then Jelmer, being a bit well, gadget savvy, he like every episode brought in new stuff, and we started streaming it live and doing like layovers, doing like a multi-camera setup. And now today is like the 19th episode of this. It's technically oriented talks, some part inspirational, some part real practical for your day-to-day job. But it's also a way to like establish some of the people with certain expertise or some kind of knowledge within Sanoma. So you know that, hey, Jarek is talking about Terrible. Well, maybe next time when I have something about automation, I could go to this guy and ask him any questions or talk to him during the beer break. So to give a really brief introduction of Jarek, we at the digital part always been busy with like automating our infrastructure. So not waiting until someone created a server by hand and installed all the software, but we want to do it ourselves with automation, because then like our test, our production environments would be the same. When we want to create a new environment, we could just replicate it again and again and again. So we take out some of the manual steps in that process, which also helps when you try to scale those setups. We've been doing that for a really long time. Arjen laid some of the groundwork for that, but it was like really server oriented, so for one server. And like a year ago, Jarek started a new era of automation where we start looking at like the whole setup. So not only one server, but looking at like the whole setup. So front-end servers, middleware, database, load balancers, the whole setup. And this immediately paid off when we did a migration. Initially, we waited for Wipro to provide a new platform also for the digital activities. At some moment in time, we decided not to wait for them anymore and go to the public cloud. And we did that with already some of the tools we had in place, but also mainly with the stuff that Jarek built and is going to demo today, which allowed us to migrate more than 1,200 servers in 4 months. So that's like, well, it's not the first migration we did, but this by far the most productive migration we've did. And although it was painful for some of the business units in the time that the development team spent on it, it was a huge success for us. Next step is like cost optimizing this new cloud setup, but that's also why we're having a hackathon in a week about optimizing these setups and really leveraging the cloud capabilities. Jarek's going to show you what's powering all that. So please take it away. Round of applause for Jarek.
Well, welcome everybody. My name is Jarek, as you already know. Well, actually, after this introduction, I have nothing more to add, I believe, but I will try. Anyway, well, I'm solutions architect at Sanoma, mainly focused on DevOps activities. As you can see on the stickers here, well, a lot of conferences, a lot of different technologies involved. But what I'm gonna try to focus on today is actually our internal product that we developed. Well, me and I need to mention one more guy, which is Marco Lebing, my colleague from my team. Without him, well, Terrible would never exist. So, well, half of the kudos for Marco. Thanks, Marco, if you're listening to us somewhere. Terrible is a DevOps tool. And first of all, we should try to define DevOps a little bit. Unfortunately, we don't have time today to do that because I have only 20 minutes. But basically, following the presentation from Kai, well, he mentioned some very interesting sentence, like working together and winning together, right? So that's exactly what DevOps means, in my personal opinion. The only difference between what we saw on the slides before and what we are gonna say about DevOps is that DevOps combines developers and operation guys, teams, whatever you call them. So basically, developers, they create applications, and then operations teams, they try to put those applications on a production environment. We know that that can lead to a lot of troubles. So basically, technology figured that combining those two things together might be a good idea. But to do that, we need to have tools. So they can enable us to do that. But I want to just make it very clear that Terrible is not only a tool, it is also kind of a mindset that you can have, that you actually should have. So this is like an idea of working together between developers and operations, and also between developers and business in the end, because, well, we are all work for one product. So, yeah. Anyway, I want to keep that presentation, as you can see, not very slide aware. So it will be like completely technical. Yeah, let's jump right into it. So what Terrible basically is? Well, Terrible is an API. For all of you who don't know what API is, well, basically it's a service running on some server, and you can access this service through HTTP or HTTPS in that case. And you can basically ask the server to perform some operations for you, to do something for you, right? So in Terrible, we don't have any nice front ends, any nice UIs, any nice admin panels. So I'm not gonna show them. Well, we only have this homepage. This is it, basically. There's a nice video that I unfortunately cannot play because we have some sound issues as far as I'm concerned. So I'm not gonna do that. What we have here is basically some documentation that I'm gonna talk about later on. So to use Terrible, or we can call API endpoints directly, or we can use our client that we also developed, which is something that you can find here. Well, those links. Basically, it's a very tiny client that is just calling API endpoints to basically help you with Terrible communication, so you don't need to use curl or web browser or something. And well, what we can do with this API? What we can do with this API? Well, basically, what we can do is we can try to deploy our applications. Here on this screen, well, this is just white letters on black screen. This is how we work. Here I have some simple application. It's really simple. It's just a HTML file that is going to show some, some stuff, as you can read from here. This is going to be running using Caddy. Caddy is a HTTPD server, very interesting one, by the way, so worth to take a look. Written in Go, yes. About the technology and some insights I'm going to talk about in a little while. So basically, if I run this, that's just going to run my application. So you can see that if we view this application, well, this is it. That's the application I'm trying to show you. And the string says that I'm running on, well, and that's the host name of the machine that it is running on. Right now, that host name is actually my Mac. This is my local machine. So now the big question is how to get this application to be running on a production environment. That's a big question, basically. That's a big question that every developer asks. Like, okay, well, I developed something, it's working on my laptop, it's running in Docker, it's running well, in some development setup that I created inside Vagrant, whatever. But now the question is, how can I run it on production? And that's a very good question, actually. and Turbo gives you an answer. So, oh, this is just a Git repository that I have cloned. Well, this is it. So the application is already stored in Git. And to be able to use Turbo, you need to go to the deploy folder directory, actually, how you call it. And here is, you store all the configuration for Turbo that is needed. I'm going to use some horrible tools like VI. If you don't know that, well, this is a text editor that I strongly recommend for everybody. So Sanoma approved, I would say. Inside this configuration directory, we used to have Puppet files, right? And so this is the same place as we had it before. Before we had Puppet and Hiera inside, and then our YAM files describing the Puppet configuration and stuff. So this is exactly the same place. But right now, we have two more directories in here. The first one is actually the directory called Turbo. And in this directory, we have one file. This is it. So in this one YAM file, we can actually describe the whole environment that we want to create. What do I mean by environment, actually? Well, first of all, that describes an environment in the cloud. So in our case, in Sanoma case, it describes the environment in Amazon, in AWS. But because we don't know if we are not gonna migrate to another cloud one day, because it's cheaper, because it's better, whatever, then we want to keep it on some abstraction layer, let's say. So that is just a YAM file that was invented by me and Marco that allows developers to actually describe the whole environment. And the environment is, well, the machines, the servers that you want to run. So in Amazon, you call them like EC2 instances, right? Then you can define load balancers. Then you can define security groups, S3 buckets, and so on and so on and so on. All those bits and pieces of the environment in the cloud. Well, in Amazon, this is it. In the Google Cloud, that will be something a little bit different, but basically the same principles apply. And in any other cloud, like OpenStack or something, again, the same story. The only difference is, well, how to use that cloud natively on like a backend layer. And that's something that is very difficult. And that's something that developers don't want to do because it's difficult and you need to know a lot of things to do that actually properly. So that's why we came up with this abstraction layer. As you can see, this is just one file. It is like, no, not too long. One screen, this is it. And in that file, we actually describe a whole bunch of things. So first of all, we define some metadata for the environment that we are going to create. Pretty self-explanatory, but well, let's go through it very quick. Well, we have a product that we're going to create, Turbo SaKE. That's a product for this presentation, but it might be nu.nl, it might be Starpagina, it might be Kieskeurig, whatever. Then we have a cluster we are going to run in, so basically the team that we belong to, and the environment, the type of environment that we are going to create. Of course, we are going to create production environment here, right? This version doesn't really matter, it's just a version of this syntax in this file because that might change in the future and we want to give us a credit to actually change that syntax and keep it backwards compatible. The HipChat room, yes, Turbo is integrated with HipChat, so you'll get all the nice notifications when everything is happening. Then, let's go to our instances in here. Those instances, well, this is basically the EC2 instance that we define here. We just say the role of that instance will be a web server. It can be whatever you decide. It might be MySQL. It can be a caching layer. It can be I don't know, API. It can be whatever you like. Then we say, well, please create only one machine for now. Don't protect it because we don't care because it's production. Yeah. In that case, we should say yes, please protect it. That means that it will be protected from being terminated in AWS. That means nothing is going to terminate that instance. This is what you want on production, believe me. Then we have disk size in gigabytes, AMI that we are going to use. AMIs are also managed by our team. The type of instance, we are going to create a very expensive one here, T2 Nano. And then, well, firewall, that translates into security groups in AWS. So we are going to open port 2020 on this instance, and port 2020 is used by CADI web server to serve content. That's why we are opening it. And we also limit the access to this machine only to internal network, basically. And then on top of that, we are going to create our ELB, which is Elastic Load Balancer, which is, well, in our abstraction layer, it's just a load balancer. We say, yeah, well, please connect this load balancer to our web server group. So if we have 10 of them, all 10 of them will be behind that load balancer. Then we can define the DNS name that we can access the load balancer under, monitoring URL, and some other stuff like listeners, and again firewall. In that case, that load balancer will be opened to the public world. On top of that, when we have that environment created, we also need to provision our machines, right? Because, well, the machine that is going to be created based on this information here will be just a very pure CentOS 7.2 from the AMI of that type, and this is it. So nothing is actually running there. This is just an operating system running there, just the CentOS 7.2. That's it. So we want to be able to tell what and how do we want to configure that machine, right? And for that purpose, we are going to use Ansible. Why did we choose Ansible? That's a completely different story, and we absolutely don't have time to cover that topic today, but maybe one day, maybe another SaKE. But anyway, for now, that being said, we are going to use Ansible. In here, we have just a very simple playbook. Oh, thanks, Sander. Whatever you're trying to do.
We can't see you at home.
Well, you don't need to see me. Now you cannot see my presentation. Oh my. Okay. So, so basically in that playbook, because this is how I call, how they call, I mean they Ansible, how they call the YAML files in here. In that playbook, we are going to use the two roles, and those roles are actually created by us, by Sanoma. It's a common role and a CADI role, as you can see here. And then we are going to include our deployment playbook that actually deploys the application that was just running on my laptop. So the deployment playbook looks like this, and it's actually pretty simple. It just downloads the artifact from S3 bucket, and then, well, unzips this artifact. There we go. There we have it. It's up and running. How that artifact goes to S3, that's completely another question and completely another story. I'm going to show that to you in a moment, actually. But before all that happens, I want to make sure that this starts to run. So we are just ready to apply Turbo for the first time. There's no environment for this application running yet. I'm going to use my application Turbo job, which is just this tiny client that I mentioned before. You can read what it can do here. Those are the possibilities that you can choose from. For now, we are just going to do go. And go means, well, apply the environment and provision my machines. So the production here comes from the file that I just showed you. I'm going to apply it. Now, we are asking the API server to actually apply the go command with this payload. This is just a payload. So use this repository, use this branch. So as you can see here, you can just version an environment very natural way using Git, and then environment production. So yeah, well, let's go for it. And now we have a couple of choices. Now we can sit here and stare at those dots that are going to be appearing very soon. We can also, well, actually verify the plan before we do that. That is just a plan that is showing you what's going to happen. And what is shown here, exactly that is going to happen in AWS. So, well, as you can see here, for example, we are going to add the AWS instance with the role web server based on that AMI, and so on and so on and so on. We are also going to create our ELB with some health checks, and this is our monitor URL that I have configured in my YAML file, right? So it's a good idea to review that, but I know that it's not going to break anything. I hope. It's a live demo, right? So let's say yes, and that number here, 1 minute 59 seconds, it's completely random, so don't pay any attention to it, just for fun. How can you predict how much time this will take? I mean, there is no way to predict that. But Apollo was trying to predict that, and we thought that we cannot be worse than Apollo. That's why we implemented that. So, yeah.
So it's like the Microsoft.
Yeah, it's like Microsoft basically. Yeah, very good, very good.
It's always ending at the end. It's always longer than you think.
Yeah. Oh, you will see that in a moment. So yeah, again, now we can watch those dots appearing here. They're pretty fascinating. So maybe I will shut up and we can watch them, or maybe not. So this will take a moment. What this is gonna do, this is actually gonna execute actions in the cloud directly, meaning, well, using the cloud API to communicate to Amazon and schedule all those operations that were listed up before. Then it's going to run Ansible to provision those machines. And it's all happening on the Turbo server. It's not happening on my laptop. So don't be fooled by this output. This is just polling the server and checking the status. But if I kill these clients right now, the job is still running on the server. So and basically there is no way to kill that job, because if that job dies, then you end up with, well, something that is unpredictable, because maybe some of those pieces are already created, some of them are not created yet, so you end up with a mess. So that's why we don't want you to kill that job.
You also do a check at the end, so everything is generated. Then you also check it again, or is it something you do manually after?
Yeah, well, no, we don't. We just assume that if that worked as it should, it's okay. We assume that because of one reason, and the reason is Terraform. What Terraform is, and actually why Turbo is called Turbo, that's a nice story that I can tell during those dots. Terraform is just an open source project that we are using as a backend for Turbo. And that open source project made by HashiCorp from San Francisco, very nice company, very cool one. We should follow them actually in terms of technology. They are doing crazy stuff. Anyway, they deliver this tool, and that tool is actually developed and designed by them to apply all the changes to the cloud. So we are just using that tool that is well tested, well maintained, and open sourced, and really solid tool. We are just invoking that tool to actually apply our changes. So we don't do that ourselves, because why to reinvent the wheel, right? If the wheel is already there. It's just very complicated to use Terraform directly, and that requires you the direct access to the cloud. And that's not something that I would like to have even. I don't want to have access to the cloud because I can break stuff. I don't want to break stuff. And that's why most developers, they should not have direct access to AWS. Eventually, that's not possible right now yet, but eventually that should be the case. So they cannot break stuff by accident.
Depending on the attributes that you use in the YAML file,
Yeah.
on this terrible versions, or do we have also that possibility to add our own attributes to the file?
Well, right now, it is actually possible to extend Turbo configuration file by adding the custom Terraform files. So you can add, let's say that CloudFront in AWS is not supported by Turbo yet natively, so in my file, because it's not. It's almost there, but not yet. But if you want to use CloudFront in your setup in here, you just need to provide your own custom Terraform file with along with my configuration, and that will be applied as well. So you can actually extend Turbo functionality using that, but that's not really recommended because, well, then you are in your own. If you break stuff, then it's like broken and nobody can help you, basically. So, but that is used by some of you. That is used by some titles already. So yeah.
We also contribute that to the open source community. So
That would be awesome, and that's something that overlaps with Miguel's presentation after me. So hopefully, well, we can collaborate on that, and hopefully we can do that actually.
because then it's also used by other companies, and you also
Absolutely.
know if there's a
Absolutely.
project or something else, somebody can find it.
Absolutely. So we just spent the whole dots time on a nice conversation here, but well, because we are running out of time, thanks Sander, we need to move on. And what we see here, well, we see basically the inventory file for Ansible, but from that inventory file we can see that that server was actually created. So let's jump into it. Yeah, it actually works. So that's a nice MOTD generated by the common role that I applied. It is, it should be running my application somewhere. Data, home, caddy. Yeah, so that is the same application that I was running before on my local machine, right? So yeah, it's deployed here. Yeah, yeah, remembering that we configured our DNS that I don't remember anymore. Where is the DNS? Oh yeah, SaKE AWS. Okay, well, let's go to this address, see if that actually works. It should show us the same, but with a different hostname. Well, basically the server hostname, right? Well, because it needs to be /SaKE, and it needs to be /SaKE index MD. Yeah. So there it is. So what we just did, we just created the complete environment in the cloud from absolutely nothing, including EC2, including ELB, including security groups, including all the stuff that is needed. We deployed the application using S3, and we have that application up and running here. In how much time? Like 5 minutes, together with talking and doing some crazy stuff. How many lines of code? Half a screen, I would say, plus the configuration file that you can actually half of generate automatically. That's cool. Well, let's do one more thing. Unfortunately, we're running out of time. That's so bad. What we can do right now is we can actually say, okay, now I want to have 2 machines. All right. So I have to scale up my environment. Let's do that. And now I want to make some change to my application as well. Where is my template? It's here. I want to make some change to the application. And that needs to be, I don't know, 2. I'm not really sure what's going to show on the screen, so sorry for that already. We'll see. And what is more, we can actually use Bamboo to deploy that, which is a pretty cool stuff. I already configured the Bamboo project for this application. So when I enable that project and I push my code to the Git, well, that will trigger Bamboo to build it, to deploy it, and this is it. Unfortunately, I don't have time to dive deep into that, but what I want to show you is the deployment plan that is here. If we go right into it, then you can see that one of the tasks is actually uploading the artifact to S3. So that answers the question how it's actually uploaded with Bamboo. And there is one more thing in here, which is that line. I'm gonna copy paste that line so you can see it. That's just the API call to Turbo. So this is using Turbo without using the client, just using the curl to actually call the Go endpoint with the same payload, as you can see. Again, branch master, environment production, our repo stuff. So let's enable this plan. And I really hope that's going to work. I don't know. Here? Yeah, enable plan. Okay. So that plan is enabled, and now we can commit our changes, demo, and now we can push our changes to the repo. That should trigger Bamboo. So let's see if that happened. Oh, actually, we are just executing the build in here. Right now, there is a big question: how do we know when that's done, when that's not done, or something? That's where the HipChat integration come in handy. We can go here. Now you can read my stuff, but here. Okay. So here starts the demo. That was when we started, actually. Those 2 first notifications, they appeared just after I created the first environment. So now we see that. And right now, what is happening right now? Right now, Turbo server is running a job. We don't see it even, but it is actually running a job. Then it's going to add the new instance. So there will be 2 instances behind the load balancer, so we scaled up. And it's going to deploy the change in our application because I changed the background. So as soon as we actually see the notification here, it should be reflected in the URL that I was visiting before without basically doing anything. And that will be black magic. So, well, let's hope that works. Waiting for that, I can also mention that because of that, the fact that we are using Ansible, we are not tied anymore to the in-house modules for that, like before with Puppet. So right now we have all the freedom to actually use Ansible Galaxy, which is just a repository of some open source, again, Ansible roles that you can actually use. So if you find a very good role for, I don't know, PostgreSQL that you want to use, or for something that is not really in-house developed yet, or never will be, you are just free to use it. Just free to use it. So you can just download that role, include that in your Galaxy file. That will be applied for you. We are actually running some of those Galaxy jobs for Turbo itself. So why not? They're pretty well maintained and pretty good. One more fact about Turbo that is worth mentioning, I would say, is the whole solution is developed in Golang. That's a pretty new technology in Sanoma. Well, there is like a astonishing story behind that fact, that why it is actually developed in Golang, not in Python, let's say. That would be an obvious choice. Well, when we were actually talking with Marco about it, then we thought, yeah, well, let's create Turbo. We had an idea, and then we thought, well, we need to implement it right now, right? So are we going to use Bash for that? Well, we might. We all know Bash, we like Bash, but is that the best choice? Well, no. Are we going to use Python for that? Well, we might again, but everybody's using Python. It's kind of boring. So then Marco said, well, you can write it in Go. Yeah, Marco, but I don't know Go. Oh, come on, you can write it in Go, right? Yeah, right, yeah, I can. And basically after 3 evenings, I started developing that, and well, it's kind of working. So that was just an insane journey across the technology, and we learned a lot. Now we know Go pretty well, actually, and now we know that using Go for implementing APIs, let's say, it's just a brilliant idea because of Go routines and because of channels. That's the concurrent design of Go language, which is just amazing, and we definitely should take a look into that. So maybe that will be an inspiration for some of you, maybe not, we'll see. Still waiting for that. You never know how long that will take. That will take.
Can we do some questions in the meanwhile?
Yeah, absolutely. Yes. Yeah, because well, we are waiting for that. After that, it's probably failed.
Hans, 1 sec, get the mic.
Yes.
What's the time that you won with this project? Because I think you have won a lot of time and a lot of hazard for a lot of people. But I think it's also good to mention what you have won with this.
Yeah, that's a very good question that I don't know how to answer, to be honest. Because Turbo right now is used by like 40% of our product. So the other 60 is still using Puppet and Apollo. So it's hard to say. But well, personally, from the migrations I did, and I made some migrations for directories cluster, well, we saved like, I don't know, 90% of the time that we would spend otherwise doing that manually. So personally, for me, it's like 90% win. For all the other guys, probably a little bit less because they need to know Turbo and know Ansible. So the learning curve is a little bit higher. But once you are at this level, it's that easy, basically. So yeah, you can save a lot of time. Probably that's a better question for Sandra, actually.
Already in like waiting, because usually you had to do a handover. You would have to ask, well, guys like Jarek or like Marco, and to do a change. And even like the smallest change, the waiting time will be 15 minutes. So in setting up an environment, you easily have to do 20, 30 changes in the infrastructure to get it right. And yeah, you can do that by hand. Hey, it's working.
Yeah.
Well, a round of applause for that.
This is actually the average Turbo user. So.
In the meanwhile, while Miguel is setting up for the next talk, some questions. Well, Hans again.
Sorry for that.
Yes.
Can you use it also not for Amazon Cloud and cloud servers? Can you also use it for dedicated servers?
For dedicated servers, you mean?
Yeah, dedicated to an in-house stored server and that sort of things.
Well, no.
No.
No, only if this is OpenStack. One last thing to mention is actually doing the load balancing right now, as we mentioned. So right now we are web server 1, 2, 1, 2. So it's actually all working. Pretty amazing, eh? I'm amazed. Well, thanks a lot, everybody. I need to hand over stuff to Miguel. So see you around.